Good day. So in this video, we are going to discuss the area under a curve using definite integrals. So what we are given on this diagram, this is the function of x and the area that is bound by the function of x, and x is equal to a and x is equal to b. Now, to determine the area of the shaded region, this can be determined using definite integrals from a to b of function of x dx. Now, to explain this further, let's get into some examples. Now, in this example, we are asked to determine the area of the shaded region that is bound by the curve y is equal to x bracket 3 minus x, and also by the line x is equal to 0 and x is equal to 2. So to do that, we have to do a definite integral of x 3 minus x dx from 0 to 2. Then the first thing that you want to do here before you integrate, you want to simplify those brackets, and that to be 3x minus x squared dx. Then we can do our integration, and the integral of that will be 3x squared divided by 2 minus x cubed divided by 3. Then remember, this is a definite integral. Then from with the limits 0 to 2. Then we can now do the function of 2. That will be 3 bracket 2 squared divided by 2 minus 2 cubed divided by 3 minus in a bracket 3 times 0 squared over 2 minus 0 cubed over 3 bracket. Yeah, and once we simplify that, then the answer will be 10 over 3 unit squared. So the area bound by the curve y is equal to x bracket 3 minus x is equal to 10 over 3 u squared. Now let's look at the example number. So in this example, we are asked to determine the area bound by the curve 4x cubed and the line x is equal to 0 and x is equal to 2. Once again, we have to do a definite integral of 4x cubed from 0 to 2 dx. Then the integral of that will be x to the power 4 with the limits 0 and 2. Then we do the function of 2, that will be 2 to the power 4 minus the function of 0, that will be 0 to the power 4. Then the area will be equal to 16 units squared. That is how you determine the area bound by the curve 4x cubed and the line x is equal to 0 and x is equal to 2. Now let's look at the last example. Now, in this example, we are asked to find the area bounded by the curve and the x-axis. So the curve is y is equal to x bracket x minus 2 and x minus 3. So before we actually attempt this question, what we want to try and do is to get those x-intercepts, because without those values, we can't do the integration. So remember, for you to determine the x-intercept, we let y equal to 0. So 0 is equal to x bracket x minus 2 bracket x minus 3. Therefore, our x is equal to 0 and x is equal to 2 and x is equal to 3. Then the next thing that you want to try and do is to sketch this curve. So as you can see, this kind of a curve is a cubic function with the x-intercepts at 0 and at 2 and a 3. So this kind of a curve, it's like x cubed. The coefficient of x cubed is positive. Therefore, the graph starts concave down and becomes concave up. So what we are asked to determine is this area bound by this shaded region. So before we actually integrate this, what you want also to do is to expand that function. So that will become y is equal to, in a bracket, x squared minus 2x, then bracket x minus 3. And this can be expanded further to be x cubed minus 3x squared minus 2x squared then plus 6x, which can be further simplified to x cubed minus 5x squared plus a 6x. Now, with that in mind, then we can do our integral. So in this case, that will be the integral of x cubed minus 5x squared plus 6x dx. Now, because the areas, they are one on the positive axis of the y and also on the negative axis. So we start with 0 to 2, first of all, this region. Then we do these ones separately. Then we add together the areas. Now, the integral of that will be x to the power 4 divided by 4 minus 5x cubed over 3 plus 6x squared over 2. That will be 3x squared. Then with the limits 0 to 2. And then we do the function of 2. That will be 2 to the power 4 divided by 4 minus 5 bracket 2 to the power 3 divided by 3 plus 3 bracket 2 to the power 2 minus function of 0. And of course, the function of 0 will be equal to 0. So, and the answer for this one will be 8 over 3. And once again, we do again the integral of that, of which this is the integral, but in this case, we put our limits is 3 and 2. So that will be minus 5x cubed over 3, then plus 3x squared with the limits 3 and 2. Then we do the function of 3 minus the function of 2. Yeah, and so the function of 3 will be a 9 over 4. Then the function of 2 will be 8 over 3. And when these subtracted together, that will give us a negative 5 over 12. So this is the area of the lower part. So, but it's a negative because the negative just shows the position of the area. So it's on the negative x-axis. Then we need to add this to 8 over 3. So when you're adding, we don't include the negative. We just say plus 5 over 12. Otherwise, it's going to subtract. So then the final area will be equal to 37 over 12 units squared. And that is how you determine the area under this curve. I hope this makes sense, and I hope to see you in the next lesson. Bye.